And with that, I'd like to welcome Claudia Schaefer from Dow to start the panel presentations. And I will turn it over to you, Claudia. Thank you for joining us.
Good morning, everyone, and thanks, Bob, for the opportunity to be here today and to share what we are doing in this area. It's really very challenging, but it's also very needed. So let me share with you some slides. Do you see my screen?
Perfectly. Great.
Okay, thank you. Okay, so I'll start my presentation by introducing who we are as a company and also the importance of sustainability along our history. So Dow is a global chemical company, and our ambition is to be the most sustainable, inclusive, innovative, and customer-centric material science company. We deliver solutions that address global needs in packaging, infrastructure, and consumer goods. And some examples of that are food packaging, which avoid food spoilage and increase shelf life, insulation materials and sealants, which are very needed for increased energy efficiency in building and appliances, and also human fluids, which increase the efficiency of solar power generation. Also, we recently launched our mobility science platform, which is focused on future challenges aligned with low carbon transportation. So let me talk now about what we are doing in the sustainability area. We have a very strong track record, and we are already on our third generation of 10-year stretch goals. The first set of goals was focused on the reduction of the footprint of our operations. Then we started to focus on our handprint, which was about redesigning products and processes with our customers and launching more sustainable products. And finally, the third cycle, which is focused on the blueprint. It is about collaboration innovation, as Sergey was mentioning in his presentation. It is about redesigning business models so we are able to deliver on the large challenges of the world, such as climate change. 2 weeks ago, we launched our new sustainability targets. And with that, we are committing with additional targets to reduce our plastic waste, to increase circularity, and also to reduce even further our emissions. Today, I am going to focus on carbon, on emissions. So our new goals are to reduce emissions by 5 million tons of CO2 by 2030, which is roughly 15% reduction compared to 2020, and also to become carbon neutral by 2050, which is aligned with Paris Agreement goals, and as Sergey was saying, is needed for us to have a better world and a more sustainable world. It's very challenging because we are a hard to decarbonize industry. So let me share with you how we are planning to get there. We have a three-pillar approach. The first one is to continue to reduce our carbon footprint in our operations. Short term, we will continue to invest in process optimization as we have been in the past almost 30 years. And an example of what we are doing, this year, we are implementing in Louisiana a new fluidized catalytic technology, which will produce on-purpose propylene. And by doing that, we expect to reduce emissions by 20%. We will also continue to increase renewable power purchase when competitive. And renewables is a very good example of technologies that were scaled up. And a good sign is that today we are already the largest chemical industry in renewable power purchasing. That's something that we wouldn't believe it would be possible many years ago. But there is a challenge. We operate 24/7 and renewable power is intermittent. And our sites operate more efficiently when power supply is constant. So let me give you some examples of how we are dealing with this intermittency. In Texas, we have wind power deals, And the supply is according to the generation of the wind power and not according to our demand. So we balance the intermittency with on-site self-generation from cogeneration plants. And recently, we signed a solar deal for Texas, which will be an additional source to firm wind, given that solar and wind are complementary sources. Another example is in Brazil, where we just closed a solar power contract with 24/7 power supply. In this case, the power producer will build enough solar capacity during the solar hours to meet our annual demand. And in order to avoid market exposure, and Brazil is a very volatile market, they closed a swap contract with hydro and wind power producers to firm a 24/7 power delivery. But the fact is that today, we do not have a 100% decarbonized grid offering yet. And the intermittency of renewables is firmed by fossil fuel-based power plants. New technologies such as battery will help with intraday balancing, but not always with seasonal variations. So again, we need further developments and further scale-ups. The second part of our pillar is to ensure our products are more sustainable than alternatives. Dow has already many products that deliver on low carbon needs and reduce emissions significantly in the value chains we serve. And we'll continue that path. We'll continue to innovate and develop more products that will help address future challenges. However, all of that is not enough. So in the medium and long term, we will need to develop step change technologies and products which are not available yet at commercial scale. This takes us to our third pillar, where we will look for collaboration towards low carbon innovation. An example is a recently announced joint development agreement with Shell to work on electrified cracking. This is one possible route for decarbonization. And if successful, power consumption will increase 10 times versus conventional technology. This is a challenge because it will require infrastructure and it will require supply of low carbon power through the grid. So it's a similar challenge faced today by the electrification of the transportation sector, which is more advanced. And while breakthrough low carbon technology is being developed, we will also need transitioning technologies such as carbon capture and storage. And again, here collaboration is required. We will need CO2 hubs. So today, we are part of a coalition in the Netherlands where we are working on options on the needed infrastructure and also governmental support. So we will be able to adopt carbon capture before 2030. We are also co-founders of the recently formed US Gulf Coast Carbon Collaborative. But let me share with you what we are planning as our path ahead. We know that to meet our new sustainability targets, we will need innovation, we will need investment, and we will need collaboration. It's about working across our value chain with universities such as MITei, with NGOs and governments to manage both risk and regulation and create value through our science-based technology. We are engaging for a dual horizon approach, where we need to balance short-term progress and long-term solutions. In order to be sustainable, the low-carbon transitioning needs also to be economically feasible. And the success has to do also with affordability and a good balance of risks and rewards, which will ultimately attract investments. In that sense, the pandemic is an additional short-term challenge for all of us, as it impacted significantly the economic reality of countries, companies, and societies globally. And climate change is a very big challenge. So the pandemic is showcasing a path on how we can deal with that, because acting together, it's much more effective when addressing major global challenges. So decarbonization is needed and is the right thing to do. And all recent issues do not change our ambition and commitment with a sustainable future. Our recently announced carbon targets in the mid of the pandemic is a good demonstration of that. So thank you very much, and back to you, Bob.
Thank you very much, Claudia, for that very interesting presentation. So I had a quick follow-up question regarding your global presence. I mean, as you've discussed, you have a footprint around the world. Could you elaborate a little bit on the challenges that presents to Dow in dealing with the different policies and requirements and resources in different countries around the world where you operate?
That's a very good question, Bob. And I think that actually, when we talk about climate, although climate is a global problem, the carbon policy and regulation is very fragmented, to your point. So, and it's changing and evolving all the time. It's very difficult to predict and to follow and to know exactly what's going to happen and how the future will look like. So I don't think this is only a problem for a global company, but it's a problem for all companies, regional or global companies. But because of the aspects of being regional, all of those challenges and all of the policies, we do have regional presence and we do have teams working regionally. But the beauty of being global is that they get connected and they start to share experiences, best practices, what worked well and what did not work that well. And this collective intelligence helps us internally to be more effective in our strategic planning and externally to be a stronger contributor when joining external forums.
Good. Thank you very much. So the next panelist is Augustine Delgado. He's from Iberdrola, as I mentioned earlier, and I'm going to turn it over to Augustine for his presentation. Thank you, Augustine.
Thank you, Bob. Thank you for inviting me to this meeting. I'm going to share some slides so we can follow better the presentation. Yeah. Can you see the slide? I think so. So as we are talking today here about scaling up low carbon energy, I would like to talk about how we are dealing about this scaling up in Spain and what are the economic and environmental impacts of the business case that we are trying to develop here in Spain. So first, I would like to set up my time framework to 2030. I know that we have to decarbonize the whole economy before 2050, and that we have to find solutions for all the energy uses that we have. But from my point of view, we have a very interesting decade ahead, and we need to stop producing CO2 emissions, and we need to really scale up in this decade from 2020 to 2030 the solutions that we have already available, as Sergey has said in his presentation. So we as electricity sector, we recognize that we have been one of the most polluters in terms of CO2 emissions around our history. And we think that now we are in our pathway to be one of the big solutions in the short to medium term, as I said, in this decade. So I really believe that the power sector is ready to make a huge challenge in how we produce, generate, and deliver electricity. And we have some technologies that are really available and ready for mass scale deployment. I'm talking for sure about solar, but I'm talking also about onshore and offshore wind, about hydro, standard hydro and pump hydro, and all of them together, I think that will deliver a very high percentage of electricity worldwide. Our projections, and I will be talking about that later on, but our projection it is that for 2030, these three renewable technologies, wind, solar, and hydro, will be able to deliver 50%, at least 50% of the electricity that the world will need in 2030. So let's say that power electricity provides a very high speed way to be decarbonized in this decade. And once we are in the process of decarbonization of the electricity sector, I think that we have to start thinking about how can we use this electricity that is being produced by green sources in the different uses in our society. And I'm talking about mobility, I'm talking about heat and cooling, and I'm talking about probably industrial uses. So let me explain you just a bit how we're going to do that in Spain. We have set up an ambitious national energy plan to 2030. So as I said, it's something that can be measured and probably is going to be accelerated due to this COVID-19 situation in which we want to use the energy sector to somehow accelerate the recovery in our country. It takes into account all sectors and all parts of the value chain. And for sure, it relies on technologies that are today available. For sure, we are also still doing research on other technologies, but for scaling up, we have to take into account the technologies that we have today available. With clear objectives: greenhouse gases reduction of 35%, final electricity generation of 74% coming from renewables, 42% of final energy, and this is very ambitious. This means that for 2030, 75% of the electricity produced in Spain will come from renewable sources, wind, solar, or water, and a very big increase in efficiency due to the use of this electricity that, as we know, has a very high impact in the efficiency in the final uses. Main drivers, it is renewable generation, it is electric vehicles, up to 5 million electric vehicles, and heat pumps to increase the efficiency in our heating system. So this is how the generation system is going to look like in 2030, and as I said, probably before that. If today we have a mix in which we have 25 gigawatts of natural gas installed and also nuclear, we are going to have in 2030 152 gigawatts of power installed, but most of it will be wind and solar. And we'll still keep some natural gas for peaking times, and we will start closing our nuclear fleet at that moment. So, and in 2030, for sure, we would have our coal fleet shut down already. So the capacity additions for 2030 will be 60 gigawatts in our country, and we also will develop new pump hydro and batteries, so we can have a system that is not only renewable and with very low CO2 emissions, but it will be also very reliable, secure, and for sure with much less imports of energy. And third, and I think this is very important, electricity will be cheaper than today, probably much cheaper than today, because the LCOE, the levelized cost of electricity of these renewable sources, is going to be cheaper. So I think we're going to achieve the three goals of sustainability for 2030 with this new mix that we are building. And I can tell you that there are more projects than are needed. So there is appetite from the industry to invest in this plan. And we are going to achieve the three goals, being competitive electricity, green electricity, and secure and reliable. And what are the effects of this plan? You can find them here. As I said, 74% of renewable generation in our power mix. If we talk about the left-hand side, the generation side, but 28% of electricity in final energy versus 23%. This means an increase of electrification of 22%. This means also 5 million electric vehicles that will consume only 15 terawatts hour compared to the 16 terawatt hour that these 5 million electric vehicles consume today with the fossil fuels, and 5 times more heat from heat pumps. Also with a very high increase on efficiency because of the high coefficient of performance of the heat pumps. As I said, efficiency of the whole system will increase by 40%, electrification will increase by 22%, and emissions in the power sector will decrease 50% versus 2005, and the fossil fuel imports will be decreased highly due to the renewable generation on site here in our country. So this is what I wanted to share with you. I think we can get this scale, and we can do that in this decade, and it can help in the recovery, the economic recovery, and it can be done with current technologies that will deliver the 3 characteristics of the sustainability: competitive price, green energy, and secure energy.
Thank you very much, Augustine. That was a very interesting presentation. Question that comes to mind when you talk about all the things you're electrifying is the infrastructure needs that you have to do that. What do you see as the stress or not in Spain? And if you could also comment on interconnectivity to other parts of the EU and whether that's important in this plan.
Yeah, it's true that to achieve this vision, you need to have a good network, both transportation and distribution network. But it's also true that we have tools to accommodate in the networks. We have better tools today to accommodate in our networks all these needs. You know that networks are designed for our peak time. But what if we can somehow shift some of these loads that we want to put into the system, like electric vehicles or heat pumps? So currently here in Spain, we have 99% of deployment of smart grids. So every hour, people see a different price for electricity. And this is going to be a very powerful tool. So we can give the customers economic signals to charge their cars during the night, or to use their heat pumps when the price is lower, because there are less demand or because there is more renewable generation. So it's true that the network in Spain is quite good, and we think that we have to do some improvement, but it's not going to cost too much at all. It's going, if you put into the pot of the electricity cost, anyway, the electricity cost for the consumer is going to decrease. So electricity in Spain is going to be deflationary.
That's great. No, thank you very much again, and it's a very ambitious and exciting program. So next, I'd like to invite Tom Fitzgerald from National Grid to talk about their strategies and the work that he's doing there. So, Tom?
Thanks very much for the introduction, Professor. It's a pleasure to be here and represent National Grid. I aim to share a few perspectives on successes, challenges, and goals the company has identified for achieving decarbonization and scaling up a low-carbon energy society to stop climate change. During my time at National Grid, I've been able to gather some deep perspectives on the nuances, challenges, and advantages of being the largest electric transmission and gas distribution asset owner in the northeastern United States. A great quote once said by Speaker Tip O'Neill is, "All politics is local." I'm a big believer in saying all energy is local too, Speaker O'Neill. Next slide. Perfect. National Grid's U.S. territory serves over 20 million people across New England and New York. We're originally a UK business stretching from southern Scotland to Wales, where we own and operate the electric and gas transmission systems for the United Kingdom. We also own and operate a handful of subaqueous transmission cables between the UK and Europe. In the US, we own approximately 9,000 miles of electric transmission assets, stretching from Buffalo, New York, to Hanover, New Hampshire, to Quincy, Massachusetts, all the way down to Providence, Rhode Island. It is a massive system with a lot of nuances composed of 62 different US operating companies. Within each of these territories, though, there are heaps of data and information one can explore that highlight the engineering and policy decisions that have been made over the past 100 years as the northeastern United States utility industry evolved out of one small town in southwestern Massachusetts. National Grid also owns one of the largest and one of the first HVDC interconnectors, supplying 10% of New England's power from Canadian hydro plants. On Nantucket, an island south of Massachusetts, we also own the largest battery energy storage system on the East Coast, rated at a whopping 6 megawatts, 48 megawatt hours. This award-winning project helped us save our customers over $120 million and is one of the largest non-wires alternative projects that I'm aware of in the world. In the same body of ocean, we also connected with the nation's first offshore wind farm. And in Queens, New York, our gas business proudly interconnected with one of the largest wastewater biogas production facilities in the country, producing enough renewable gas to heat 5,200 homes throughout the city and help curb roughly 90,000 metric tons of the state's annual greenhouse gas emissions. All these projects are efforts that should be studied closely for every policymaker and utility company across the country, and is a reflection of what a low carbon future must contain. Next slide. Excellent. National Grid has strong and important ambitions for reducing our contributions to anthropogenic climate change and overall implementing carbon neutrality by 2050. The challenges of utilities in the Northeast are really quite complex, and in many ways, it's harder here in the Northeast and more complicated than elsewhere in the country. Some of the major issues Northeast utilities encounter on almost a daily basis include land availability, asset age, and real-time climate change impacts. I will start with highlighting that to achieve 40% emissions reduction in 2030 in the power sector, we need a complete comprehensive shift in production in our ISOs, particularly in New England. Significant transportation behavioral change, and we need to up our fuel oil to gas and electric heat conversion rates drastically, as you can see. As you can see also, 67% zero carbon system power production is significant. That's a pretty difficult goal. And it's even more difficult when over 60% of New England's power comes from gas turbine facilities that were converted from legacy coal plants. Oh, and all of our nuclear power plants are retiring early along the way. I'm not sure if Professor John Parsons is attending today, but you should ask him about how expensive we are making it for ourselves by retiring nuclear power resources. Coupling the decarbonization of power issues, we in general as Americans have a vastly underutilized and underbuilt public transit system. So many end up driving everywhere, especially in the Northeast. In COVID, and especially the general times that we live, this issue has become even more aggravated. So really, our 2030 goals also mean that we need to have upwards of 10 million EVs on the road, 20 million in the long term. And ideally, to make this needed shift more attainable, we also should be taking public transit whenever possible. 2030 is only 10 years away. And with the last year's EV sales reflecting only 1% of US auto sales, we have a steep curve ahead of us. I do believe these transportation objectives can be achieved though, but it has to be done through comprehensive regional efforts to eliminate range anxiety, and regulators, utilities, and corporations together need to promote the construction of ultra-fast charging networks, similar to what Tesla has done, only instead making them available for all autos. If I could synthesize our decarbonization goals in this slide in particular into one statement, I would say we can make these goals, but it's only if we have a robust, intelligent transmission network, leveraging 21st century technologies, addressing proactive asset management needs, and enabling large-scale transmission and renewable projects to work hand in hand to power our economy. We also need our governors, regulators, corporations, and utilities across the Northeast to be discussing and driving tangible regional projects. Speaking of regional projects, this brings me to my next slide. Transmission is the great barrier and the great opportunity for achieving a low or zero carbon society. At National Grid, almost all of our work involves engaging hundreds of stakeholders, government representatives, and regulators. And to boot, oftentimes we actually don't even own the land we are trying to rebuild our infrastructure on. I speak for our customer and commercial services teams when I say that regional infrastructure projects are difficult, but not actually owning the land makes it even more difficult. Most of National Grid's electric transmission lines are actually right-of-ways without an easement. As a result, the company is forced to think innovatively and creatively to meet customer needs and have authentic and personal conversations, bringing climate issues to the forefront of our customers and services. Generally speaking, I speak for my colleagues here as well when I say that in the infrastructure world, there's a lot of talk about NIMBYism, or not in my backyard. But for National Grid and other utilities in the Northeast, it's different. A great term I like to use that is more realistic is no bananas, or no building anything near anything, never again. So for us, the customer is really the first person in mind. We constantly ask ourselves, does our customer need this? Yes. Does our customer want this? Maybe. So we have to ask ourselves constantly, what is the lowest impact pathway to meet the needs of our customers and provide the best-in-class industry solution? We're exceptionally aware of our customers, how we can help them, and how we can provide the highest quality power and heating solutions with the lowest possible disruption or negative impacts. Transmission is stalled, however, and is slow moving for this reason, amongst others. This brings me to my next point, asset age. National Grid has some of the oldest power assets in the world, literally. I have poles in Western Massachusetts and upstate New York that were cut and milled in the Adirondacks and put into service as early as 1912 that are still in service today. We have assets over 100 years old, really. A big piece of the future of transmission and the future of decarbonization, in my opinion, and what we believe, is what we call bundling in the transmission space, where we think about not only replacing the asset with its new equivalent, but what other items need to be integrated into the project to make sure we meet policy objectives, load needs, system flexibility, and virtually all other possible stakeholder requirements. Not only do we need to rebuild significant parcels of our transmission network, we also need to leverage the system to decarbonize. Talk about a big leap, but a necessary leap. Many other transmission operators and industry experts can take note for both what being a proactive and mature asset manager means, but also policymakers and climate advocates should take note how companies like National Grid can be leveraged to achieve steep and necessary climate objectives. Transmission is critical and is one of the most undervalued and most poorly understood players in the energy and environmental world. Some of the quotes I include here, you can see from a Bloomberg article talking about 230 gigawatts of wind projects required transmission interconnections at the end of 2018, and most of them won't come to fruition if transmission interconnection is not feasible. I also quote an MIT CEPR paper that really talks about how to electrify California, you need upwards of 25 gigawatts of power. Another piece I don't show here is the need to preserve and conserve our forests and build where land cannot be reforested. There's also scaling up in this space as well. As a transmission analyst, I will also say that no transmission project should outwardly require large-scale deforestation either. These trees we affectionately label in the industry as vegetation are actually critical to our ability to achieve carbon goals. I like to say intelligent transmission networks don't have just vegetation management needs, they have natural capital needs as well. National Grid leverages state-of-the-art vegetation management practices by promoting native plant species growth and uses its properties for promoting natural pollinators and does targeted herbicide spraying for removal of invasive species. Next slide. As you can see here, there's a lot of EV goals for the Northeast across multiple states. To be able to achieve these transportation goals most economically, policymakers and regulators should leverage utilities and transmission owners to execute on large-scale charging sites for public and fleet charging purposes. This is a big part of our team's future work. These require regional planning efforts, and regional charging locations need to be constructed to create an e-drive network from Boston to Buffalo. Our team's goal is to eliminate range anxiety and throw away charging time trauma so anyone can drive anywhere in the Northeast, pull off the interstate, plug in their car, and charge their battery from 0 to 80% in 5 minutes or less. Home charging and work charging have their places as well, but if we look at what has been done in Norway, Sweden, and elsewhere, they have a regional ultra-fast charging network. It works for large-scale conversion. I also personally believe the burden of charging infrastructure at workplaces can be complicated. Employers don't necessarily see the value of adding another expense to their bottom line, and building managers are not necessarily interested for the same reasons either. I would also pose that home charging is a privilege for people who can afford a home, and in most cases, those who also own a garage. Most Americans don't own homes, and even fewer have garages. Ultra-fast public and fleet charging is a critical part of the story to bridge the adoption gap and bring us into the future. National Grid can play a significant role in supporting this transition. Next slide. And this is the last piece. The last piece I have to share is about climate change impacting us today and now. When we see these climate goals, we tend to think of climate change in the future. However, it's not some distant problem in the future. It's impacting us here and now today. We may not realize it sometimes, but humans experience climate change accelerated events on a daily basis. Most recently, here in New England, we've actually been in almost a 3-month drought. New England is one of the wettest places in the country behind the Pacific Northwest. Yet in the past 10 years, we've had 4 separate drought events. Crazy. Hurricane Sandy is another example, But there are countless others that I could speak to as well that are impacting our businesses in real time. To meet these organizational risks, the company has several resiliency initiatives ongoing, everything from traditional items like concrete foundation and lattice structure to monopole structure conversion, but also thinking more innovatively for how to prevent wind, temperature extremes, and icing impacts. As a result, National Grid retained Sergey Paltsev and Muge Komarku for MIT's Joint Program on the Science and Policy of Global Change to run a series of supercomputer weather event forecasts between 2025 and 2041. This study is state-of-the-art and will be looking at our entire US service territory in a 3D grid format of less than 3 square kilometers. I've got to speed up here and wrap up. So the last thing I'll share is that this work is critical, proactive, and in the best interest of our customers and regulators as we work to reduce emissions. Utilities can and should work with Sergey to conduct these studies on their own service territories. And trust me when I say this, these data sets not only help transmission companies, but virtually help all companies assess all business units, assets, and even create additional value for investors. Thank you very much for the time today. I'll take any questions now or later.
But I think there are quite a few questions. I think we're going to have to stop short of those in the interest of time, to be sure to give Vijay time for his presentation. So thanks very much, Tom. Very interesting presentation. So last but certainly not least, the final panelist is Vijay Swara from ExxonMobil. He's going to talk about his perspectives and ExxonMobil's perspectives on the challenges of scale ahead of us. Vijay?
Thanks, Bob. Let me share my screen here real quick. Hopefully you can see the screen. First off, thank you so much for the invitation to speak at this. It's an honor to be part of this panel. It's an honor to be part of this event, and certainly appreciate the multiple people, over 500 I see, that are joining this. I'm going to try to build off of the comments that have already been made, to not repeat, but to build off of it, because I think there's been some very good points made. But before I do that, I just want to hopefully wish everybody well, hope everybody's safe, hope everybody is doing well in these unprecedented times. And I certainly hope everybody continues to maintain well as we go through this pandemic. You know, this is a scale challenge, is what you talked about, Bob, and then Sergey, you posed it very well. This is a big scale problem, and I'm going to talk about that. How do we go about doing this in terms of scale? And I've just got some simple charts to talk about that. So the first one is energy is needed. Look, we couldn't be doing this meeting virtually without energy. The internet, the computers, everything requires energy that's around us. And yet we have to be humble and recognize that there's 1 billion people that don't have access to energy. And another 2 billion people come into the planet, largely in the developing nations. And this chart simply depicts the fact that energy is required to improve living standards. The blue dots are the developed nations, the red are the developing. And you can see as you move up the UN Development Index, which is education, it's cost, it's standards of living, etc., you can see that more energy is needed. And the scale, 1 billion people don't have access to energy today, and 2 billion more are coming to the planet by 2040. So that's scale point number one. And the fact that we can actually find a pathway to get everybody their energy is actually quite astounding, because 30, 40 years ago, that wasn't a certainty. Today, because of technology, we have the ability to actually find pathways to develop and deliver energy at the scale that's needed to move up this development index. Of course, there's a challenge though, and that is around emissions. So as you're providing more energy and people are accessing more energy, emissions go up. And this chart simply shows that again, with the developing nations being the predominant source of emissions as you go out to 2040. You've already heard from the previous speaker that there are technology options to reduce these emissions. But what we're trying to do now is meet what we call the dual challenge, which is moving up on eradicating energy poverty, providing middle classes to grow, while reducing emissions. For that, we believe that a technology set is needed. Another chart that really depicts scale, and I don't have to go through this chart. This is available up on our website on our Energy Outlook, and you've seen some other scenarios talked about today. But the bottom line here is when your axis on a scale, when the y-axis is quadrillion BTUs, that is scale. And when your x-axis is decades, that is time. And that is the challenge of energy. It is scale and it is time. And what you see as we go from 1860 to 2040, you see a lot more options. That's really exciting. There are more options today than we had. Options continue to come forward. As Sergey said, there's no singular solution. As the previous speaker spoke, there's a geography piece to it. There's a technology piece to it. There's a policy piece to it. There's an infrastructure piece to this. All of this has to come together. Because every engineering, every science, every discipline is needed. And that's why these centers at MIT become so pivotal as we try to develop solutions here. So what is required at scale? You've already heard about some of these, but we obviously need some form of negative carbon capture and sequestration, biofuels for heavy duty transportation, because you're going to need an energy density to move airplanes, process intensification, doing what we do more efficiently, wind, solar, grid storage, that's just a subset. These all will be needed at a scale beyond anything that we've demonstrated to this point. And what are the enabling technologies? These are on the adjacencies, but computing. Think about what we're able to do with computers today. Now imagine a world with quantum computing. That should advance material design. That should advance optimization at scales that we've never seen. And then biology. From bioconversion to natural sinks, understanding the role of biology and how biology can complement energy is very important. So there is room for optimism because there's a lot of options. There's a lot of technologies. It is about integrating them together. It is what this institute is trying to do. It is what collaboration is needed to do. So in my final slide, I just want to talk about, well, how do you do this? And how do you do this faster? So this is what we call the innovation value chain. And let me just talk you through visually who's on this stage. So the gentleman to the left is me. I'll come back to me in a minute. Lynn Liu is the woman sitting to my left. She is the head of the Princeton Energy Center, and that is academics. Academia, as you know, is where a lot of the technologies are first developed, first discovered. The fundamentals, the underlying principles behind a technology are developed and discovered and discussed at universities. That's a very important piece of innovation. The gentleman to Lynn's left is Martin Keller. He's the head of NREL, National Renewable Energy Lab. We continue to work with national labs because they have the ability to take ideas and demonstrate them at the pilot scale, a small scale. And then the gentleman to his left is Oliver Fetzer. He's the CEO of Synthetic Genomics, our partner in advancing algal biofuels. Now, normally you would do this in series. You would go from academics, national lab, to small companies, and then ultimately to a company like ours that has the project expertise and the engineering expertise to do things at scale. What we are trying to do to advance innovation faster is work this in parallel processing instead of in series. So we work with Princeton, we work with NREL, we work with Synthetic Genomics and many other companies in parallel to try to advance innovation. This is a deep technology challenge. It's going to require innovation and collaboration in ways that we haven't done in the past. But there are options, as you heard earlier today, and there will be more options continuing to come. And our role as a science community is to develop these technology options with that pathway to scale. So Bob, I'm going to leave it at that so we can get back on schedule. But I just wanted to thank you again for inviting me to this. And it's just an honor to be on a panel as solid as this panel. Thank you.
Thank you very much, Vijay. That was great. You answered some of the questions I had about how to accelerate this process and how well that is going, and whether you're doing experiments there, and also question about whether you see some key technologies that are missing here that we need to focus on. You mentioned a few for negative emissions, some tools like quantum computing and so on. Are there others, or do you want to mention? Or
well, I think there are. I think one of the ones, and Bob, you at MIT have been developing this, is a way to do integrated assessments to compare systems. LCA, life cycle analysis, life cycle assessment, that is often talked about, but is really, really hard to do, as you well know. And I know you've been working on that for several years now, you and your team, and I think that's an important tool. So we have a calibration to be able to do these integrated assessments, to be able to do these comparisons and roll in the techno-economics, right? So not just do it purely from a science standpoint, but bring in the economics. And the other thing I will tell you, which is counterintuitive, but while we're doing this, a very important element is in fact patience. Research takes time. And then there's a time that's going to be taken to build out the ideas at scale. And so we need to have vigorous debates. We need to have good discussions. We need to challenge each other. And we need to be constructively, inclusively, so we can come up with the best options to provide energy while addressing the risk of climate change.
Good. Thank you so much,
Thanks,
Vijay,
Bob.
for taking part in this. And thanks to all the panelists. So I'd like to turn to our final participant to provide some comments, summary comments on the panel discussion. And that's Professor Henry Jacobi, who's the William Pounds Professor of Management. He's emeritus in the MIT Sloan School of Management. And he, I think maybe relevant to this, he was the founding co-director of the MIT Joint Program on the Science and Policy of Global Change. So with that, I'll turn it over to Jake to make sense of all this for us. Thank you.
Thanks, Bob. What a great discussion. I just have a couple of concluding points. As I listened to this discussion, a quote came to mind from F. Scott Fitzgerald. He held that intelligence was the ability to hold two opposing ideas in the mind at the same time and remain the ability to function. And that's the situation that we're in. I mean, here we are in this session dealing with two conflicting ideas. There's the urgency of the emissions targets and the scale of the task and its implications. That is the notion of net zero in a matter of decades versus realism. I don't know that holding these two ideas in the mind at the same time is necessarily a sign of intelligence, but perhaps for the people in this call, it's perhaps a sign of dogged determination. And that's what I think we've got to have. To deal with this challenge, that's what we need. Simultaneously, not to be foolish, but not to give up. The second point I would make is that it's long been the view of the Joint Program on Science and Policy of Global Change and the Energy Initiative and other NIT groups that the key to progress on the climate issue was the key to make progress, or the ability to function in Fitzgerald's terms, lies in the integration of the natural and social sciences and technology. Now, in a university, you have to admit that we definitely need people with a laser focus. You need experts on particular technologies who have no interest in the business case, or you need people who know the economics who totally dismiss the politics. And we need political advisors and analysts who have no understanding of the technical feasibility. We need those people. But progress, I think, here lies on our ability to integrate these things, to simultaneously hold these things together, these disparate parts. Because the solution lies in being simultaneously practical about the technology and finding efficient ways to handle the economics, supported by government policies and really importantly, effective institutions, rule of law, stability of contracts, and in the process to provide attractive opportunities for the companies that will make the investments that lie behind all this discussion that we just went through. And that's what this session was about in my mind, pulling together the technology, the economics, the business challenges, the opportunities. And I think it's just crucial that we keep at this, living in this tension, holding these two conflicting ideas simultaneously in our minds, pushing on. I guess it's my view, if you're looking for useful work, you don't do better than this. Thanks, Bob.
Thanks very much, Jake. That was a terrific wrap-up set of comments to a great panel and set of participants. So thanks. Let me give thanks again to Sergey for his leadership in this. To the panel again, Claudia, Augustine, Tom, and Vijay, and again to Jake for his very insightful summary comments. It is in fact a time where there are many disparate ideas we have to hold in our head at the same time. I'd also like to thank CJ and ILP for working with the Energy Initiative since our beginning, and in particular with help around setting up this series of webinars and this one in particular, and give a call out to MITei's Associate Director, Lou Carranza, who was very instrumental in helping to identify and put together this really extraordinary set of panelists. So thank you all for participating in this. I wish we had a lot of great questions that were submitted in the Q&A. We got to almost none of them because of time constraints, but thank you all for clearly being very involved in listening, and look forward to seeing you on future webinars or at MIT once we all get opened up and able to travel again. CJ, let me turn it back to you.
Okay, thanks, Bob, and thanks, Jake and Sergey, and all the panelists for a very informative session. Special thanks to over 600 of you joining us from around the world, some in those late evening times. We're sorry that many of the questions were not answered because of time constraint, but we hear you. We thank you for your input. Now this session may be about to be over, but our hard work to a low carbon energy transition will not. And our active engagement with the industry, with all organizations working in this area is surely going to be continuing. In fact, in this Friday, July 10th, we're going to organize a startup exchange session, inviting several startup companies to talk about the challenges in this energy scaling up process. So you're invited to that, definitely. You can check it out at startupexchange.mit.edu. So we hope to see you there. So in this special challenging time, I hope everybody stay well, stay healthy, and thank you. We'll see you in other occasions. Bye.